Hello everyone, this is K. Bhargavi, Assistant Professor in EC Department. In this video, we'll talk about modulation. We'll see that what is modulation, why it is used in communication system, and what are the different types of modulation techniques are there. First, we'll see what is modulation. Before going to modulation, we'll see what is communication. In a broad sense, the communication is the exchange of information in the wired or wirelessly between 2 points. Here, for example, if we consider a voice signal, it will be up to 3 kilohertz. And if we consider an audio spectrum, it varies from 20 hertz to 20 kilohertz. This low frequency signal or message signal is known as baseband signal. Sending of this low frequency signal from one point to large distance, means from sender to receiver, is somewhat difficult. It may be affected by noise easily. To avoid that problem, we'll mix or we'll add this signal to a high frequency signal, which is known as carrier signal. Whereas the low frequency signal we are calling as baseband signal, message signal, or information signal. To send it to large distances, we are adding this low frequency signal to a high frequency signal, which is known as carrier signal. Here we are using a carrier to share the low frequency signal, to move or to share the low frequency signal to high frequency. The combination of the combining of low frequency signal with high frequency signal is known as modulation. Here, see here, this modulation can be done in 3 ways. Whatever the signals will have 3 characteristics. The signals will have amplitude, frequency, and phase. Changing of these parameters, these 3 parameters of a signal is known as, we may change these 3 parameters of a signal. Depending on our application, we will change any one of the characteristic of carrier signal with respect to message signal is known as modulation. Changing the characteristics of carrier signal with respect to message signal is known as modulation. Here modulation is nothing but adding information to a carrier signal. If you see on screen, we can see the block diagram of a modulation system. Nothing is that we'll take a baseband signal, a RF signal. RF signal is nothing but high frequency signal. Baseband signal is a low frequency signal. By using a modulator, we are adding these 2 signals. After adding these 2, we'll use one power amplifier or any amplifier. We are using amplifier to amplify the low frequency signal. We'll amplify the signal and we'll give it to channel. Need for modulation. Why we need modulation? Here, to reduce the size of antenna. To reduce the size of antenna, we are using this modulation technique. Or to reduce the interference. To reduce the interference, we are using modulation techniques. Or to allow multiplexing of the signals also, we are using modulation. To do these all, we are using modulation techniques. If we are going to send a low frequency signal, by using to calculate the height of antenna, the height of antenna will be very high. If we take a high frequency signal, the height of antenna will be reduced. For this reason, we are adding a low frequency signal with high frequency signal. By adding this low frequency signal with high frequency signal, we can reduce the height of antenna. If the low frequency signals are mixed together, there may be a clumsiness, there may be a no voice clarity. To avoid that problem also, we are using modulation. This is a modulation system. Modulation system. The modulation system is having source and destinator. In between the source and destinator, we are sharing information. In between these 2, source and destinator, we are using source encoder, channel encoder, modulator, and a channel. It may be wired or wireless. And at the same time, demodulator, which does the reverse operation of the modulator, and a channel decoder. Same. Whatever the encoding process we do, the decoding, the reverse operation will be done at channel decoder. And again, source decoder. Next, destinator. This is a modulation system. And next, coming to classification of modulation or types of modulation. Here modulation is divided into 2 types. continuous wave modulation and pulse modulation. In continuous wave modulation, the message signal is a continuous wave signal. Whereas in pulse signal, the carrier signal is a pulse signal. If you see here in continuous wave modulation, it is again classified into amplitude modulation and angle modulation. Whereas in amplitude modulation, amplitude of the signal is going to modulate. Amplitude of the amplitude of the carrier signal is going to vary with respect to amplitude of the message signal. Same in angular modulation, angle of the signal is going to vary. Angle of the carrier signal is going to vary. Here the angle may contains frequency and phase. Again, this angular modulation is classified into two types: frequency modulation and phase modulation. Whereas in frequency modulation, frequency of the carrier signal is going to vary with respect to the characteristics of amplitude message signal. In phase modulation, phase of the carrier signal will vary. Next, coming to pulse modulation. In pulse modulation, again it is classified into digital modulation and analog modulation. In analog modulation, again we have pulse amplitude modulation, pulse position modulation, and pulse width modulation. It may be also known as pulse duration modulation. Here, pulse of the signal is going to vary. Pulse of the carrier signal is going to vary. In this pulse modulation, again we have digital modulation technique, which is a PCM, pulse code modulator, which is used to convert analog signal to digital signal. Along with this, we have digital modulation techniques. In digital modulation technique, the message signal is a digital signal. The message signal is having a digital information. Whereas in analog modulation, the message signal is a continuous waveform. In analog modulation, we have amplitude modulation, frequency modulation, and phase modulation. While coming to digital modulation, we are having again three types: amplitude shift keying, frequency shift keying, and phase shift keying. Amplitude of the signal is going to vary, frequency of the signal is going to vary, phase of the signal is going to vary. These three are the digital modulation technique, and above three are the analog modulation techniques, and we have different pulse modulation techniques, which are pulse amplitude modulation, pulse width modulation, and pulse position modulation. These are the different types of modulation techniques. We'll see about all these in brief. First one is amplitude modulation. Amplitude modulation is the process of varying the instantaneous amplitude of carrier signal with respect to the instantaneous amplitude of message signal. This is the amplitude modulation. The mathematical representation of this amplitude modulation can be written as A cos omega ct plus m of t into cos omega ct, where the message signal is m of t. We treat message signal as m of t and carrier signal as A cos omega ct. This is a graphical representation of amplitude modulation. If you see in the graph, the first one is modulating waveform, which is nothing but our baseband signal, which is having low frequency. And the left side, we can see the carrier signal. By combining of those two, we'll get an amplitude modulated wave, which we can see on the is about amplitude modulation. In amplitude modulation, the amplitude of the carrier signal is going to vary with respect to amplitude of the message signal. This is the frequency spectrum of amplitude modulation. Frequency spectrum representation of amplitude modulation. See here, it is having two sidebands, lower sideband and upper sideband. The bandwidth of lower sideband is Fc minus F1, and the maximum bandwidth of the upper sideband is Fc plus Fn. By subtracting these two, we'll get the actual bandwidth of the amplitude modulation, which is 2Fm, where Fc plus Fm minus of Fc minus Fm. By doing calculation, we'll get the total bandwidth as 2F. Again, we'll see the types of amplitude modulation techniques. Two levels of the next 8 PSK, 16 PSK representations. QAM, quadrature amplitude modulation. To get the better output, here we are combining the FSK and PSK. The merits of digital signals. Here the power efficiency is low by using digital modulation techniques, and the bandwidth usage is also low by using digital modulation techniques. Next, we will see the pulse modulation techniques. There are three types of the pulse modulation techniques: pulse amplitude modulation, pulse width modulation, and pulse position modulation. These three are the continuous pulse modulation techniques or analog pulse modulation techniques. The digital pulse modulation technique is pulse code modulation. We can see the representations of one by one here. The first one is PAM, pulse amplitude modulation. By using the message signal's amplitude, the pulse's amplitude is going to vary. In pulse amplitude modulation, the amplitude of the pulse is varies with respect to amplitude of the message signal. While coming to pulse duration modulation, pulse duration modulation or pulse width modulation, width of the pulse is going to vary with respect to amplitude of the message signal. Width of the pulse is going to vary with respect to amplitude of the message signal. The another one is pulse position modulation. Pulse position modulation. In ppm, position of the pulses is vary. Here the duration and amplitude of the pulses is constant. Only the position of the pulse is going to vary in ppm, and ppm depends on PWM. The output of the from the output of pulse width modulation, we will get the pulse position modulated signal. And the last one is PCM, which is used to generate, not to generate, which is used to convert the analog signal to digital signal. In this, we have three blocks: sampler, quantizer, and encoder. Sampling, quantizing, and coding we are using to convert analog signal to digital signal. Thank you.